Hello friends, welcome back. Today we will explore step-by-step guide to PCB design. This tutorial will walk you through the crucial stages of PCB design from creating schematics to final manufacturing. We will delve into fundamental concepts, explore various software options, and share top strategies for ensuring a successful design. Step 1. Prepare your schematic. Complete your schematic. Ensure your schematic is accurate with all components, connections and labels correctly assigned. This forms the foundation for your PCB layout. Assign footprints. Footprints represent the physical layout of components on the PCB. Ensure each component in your schematic has the correct footprint. This can be done within your schematic tool. Step 2. Choose PCB design software. KiCAD, free and open source, it offers comprehensive tools for schematic capture and PCB layout, great for both beginners and professionals. Eagle offers an extensive library of components and footprints, useful for commercial and hobbyist projects. Altium Designer, professional grade software with advanced design features, ideal for complex and large scale projects. EasyEDA, user-friendly and web-based, making it accessible from any device, integrates with component suppliers for easy part procurement. Step 3. Create a new PCB project. Import schematic. Start a new PCB layout project and import your completed schematic. This creates a netlist which defines the connections between components. Set up board dimensions. Define the dimensions and shape of your PCB based on your project requirements. This can be adjusted later if needed. Step 4. Place components. Position major components. Begin by placing connectors, power supply components and large ICs. These are often fixed by mechanical constraints or optical placement. Arrange other components. Place smaller components like resistor, capacitors and small ICs around the major components. Group related components together to minimize signal path lengths. Step 5. Route traces. Manual routing. Start routing traces by hand. This gives you full control over the path of each trace, which is crucial for high speed or sensitive signals. Auto routing. For complex designs, auto routing can be used. However, manual adjustments are often necessary to optimize the layout. Layer management. For multi-layer boards, plan which layer will carry signals, power and ground. Typically, the top and bottom layers are for routing, while inner layers are dedicated to power and ground planes. Step 6. Add power and ground planes. Create planes. Add dedicated planes for power and ground. This helps reduce noise and improve signal integrity. Ensure these planes are continuous and have good coverage across the PCB. Connect components. Use vias to connect components to the power and ground planes. Ensure all relevant components have proper connections. Step 7. Design Rule Check DRC. Run DRC. Use your software's DRC tool to check for design errors like short circuits, unconnected pins, and spacing violations. Fix issues. Address any issues identified by the DRC tool. This might involve adjusting trace widths, rerouting signals, or repositioning components. Step 8. Add silkscreen and annotations, labels and identifiers. Add component labels like R1, C1 and identifiers to the silkscreen layer. This aids in assembly and troubleshooting. Orientation marks. Include marks to indicate component orientation. Example given, polarity indicators for diodes and capacitors. Step 9. Generate Gerber files. Export Gerber files. Gerber files are the standard for PCB manufacturing. Generate these files from your design software. Each layer, copper, solder mask, silkscreen, will have its own Gerber file. Generate drill files. Create drill files specifying the locations and sizes of holes for component leads and vias. Submit for manufacturing. Choose a PCB manufacturer based on factors like cost, turnaround time and quality. Upload your Gerber and drill files to the manufacturer, often through their online portal. Place your order and wait for the boards to be fabricated and delivered. I hope you gain enough knowledge about PCB designing from this video. If you like this video, then please like, share and subscribe to my channel. Thank you.